हेलो एवरीवन, ए वेरी वेरी गुड इवनिंग ऑल ऑफ यू। कैसे हैं सब लोग? व्हाट्सअप प्लीज गाइज, प्लीज डू लेट मी नो इफ आई एम ऑडिबल एंड विजिबल टू यू ऑल सो दैट वी कैन स्टार्ट द सेशन। जैसा कि आप देख पा रहे हैं, द सेशन इज द न्यूमेरिकल प्रैक्टिस सेशन ऑन कंडक्शन मोड ऑफ हीट ट्रांसफर। So you guys are watching me live through the beautiful series which is GATE Champion series. In this series we are going to cover more than 500 questions of your mechanical engineering syllabus for GATE examination, and the difficulty level of those questions will be as per the GATE difficulty level. So through the question practice only we will discuss the related concept. If you have any doubt in any of the concept related to conduction, you can always let me know through the comment section. Hi Jabir, good evening, welcome. कैसे हैं सब लोग? Please guys do write me in the comment section if I am audible and visible to you all so that we can start our beautiful session at the earliest. This is my introduction for those who are attending the class for the very first time. My name is Chandra Shekhar, mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in GATE, IES and PSUs. I also cleared engineering services examination, worked in SAIL, and I am quite comfortable in these many aspects of mechanical. अगर आपने मेरे टेलीग्राम ग्रुप को ज्वाइन नहीं किया है, if you are new, then you can join me on the Telegram. That is Mechanical by Chandra Shekhar, and the link is also mentioned on that. Or you can always contact me through the mail ID which is there. चलिए start करें. Are you all ready with your calculator, notebook and pen? You are supposed to solve the questions and I will just assist you with the solution, with the concept, but you are supposed to do the calculation. And one more important announcement before moving further. On 6th of September, Ravindra Sir will be coming live and he will discuss the basic things to be done to crack GATE examination. That will be workshop, and you can enroll yourself, you can register yourself. That is completely free of cost. All right, and the session is on 6th of September at 8 p.m. Chaliye, let us start with the first question. The question, it is the common data question. क्वेश्चन पढ़िए और जवाब दीजिए. In a two-dimensional body, x and y coordinates are given. In the two-dimensional body, the gradient, the temperature gradient at the surface A is found to be dt by dy at surface A is given as 30 Kelvin per meter. dt by dy at surface A, ये surface A है, this is the surface B. The diagram is little incorrect. Surface A and B are not insulated. Surface A and B are not insulated. The rest part of the body is insulated. So surface A and B are available for heat transfer. You need to find out the temperature gradient in y direction at surface B. What is the correct answer? Everyone, do let me know. क्वेश्चन को पढ़िए और समझिए. सरफेस A is, ध्यान दीजिए, सरफेस A is पैरेलल टू x एक्सिस, सरफेस B is पैरेलल टू y एक्सिस. अगर कोई सरफेस पैरेलल टू x एक्सिस है, इसका मतलब टेम्परेचर इज नॉट वेरिंग इन x डायरेक्शन बिकॉज द टेम्परेचर एट A is given as 0 डिग्री सेल्सियस. सारे के सारे पॉइंट्स का टेम्परेचर 0 डिग्री सेल्सियस होगा. तो अगर मैं पूछूं dt by dx at surface A, your answer will be 0, isn't it? Similarly, y is parallel to, because temperature at A is not a function of x, dt by dx at A will be 0. Similarly, B is parallel to y axis, surface B is parallel to y axis. इसका मतलब सारे के सारे पॉइंट का टेम्परेचर 100 डिग्री सेल्सियस है. तो टेम्परेचर एट B is not a function of y. अगर टेम्परेचर एट B y डायरेक्शन में वेरी नहीं कर रहा है, तो dt by dy at surface B will be 0. Isn't it 0? Option B. समझ में आया क्वेश्चन? अगर कोई सरफेस का टेम्परेचर कांस्टेंट है, सरफेस ए का टेम्परेचर 0 डिग्री सेल्सियस है, सरफेस बी का टेम्परेचर 100 डिग्री सेल्सियस है, B is parallel to y axis, so all the point in the surface B are at the same temperature, that is 100. It means the temperature is not a function of y. At surface B, temperature is not a function of y, so dt by dy will be 0. Option B is the correct answer. Option B is the right answer, isn't it? Is this clear or not? Let us move to the next one. Now the second part of the question is you need to find out the temperature gradient in x direction at surface B. The temperature gradient in x direction at surface B. अब देखिए, because point B, surface B is at 100 degree Celsius and surface A is at 0 degree Celsius, heat will flow from surface B to A. The heat will always flow from high temperature to low temperature. So there is a heat entering from surface B and there is a heat leaving from surface A. So because there is no heat generation, there is no mention about heat generation, there is no mention about heat stored, both will be 0. So we can say Q, the heat flow will be two-dimensional, Qx plus Qy, or we can say Q in is equal to, from the energy equation, what is the energy equation? Q in plus Q generated is equal to Q out plus Q stored. That is the basic energy conservation equation. This will be 0, this will be 0. So Q in will be equal to Q out, and heat is entering in x and y direction at surface B is equal to Qx plus Qy at surface A, isn't it? And dt by, from the given diagram we can say dt by dx at surface A is equal to 0. So what does that mean? It means Qx at A is equal to 0. There is no heat transfer in x direction. Similarly, dt by dy at surface B is equal to 0. It means Qy at B is equal to 0. Because Q is equal to minus Ka dt by dy. So the heat transfer rate in x direction at A will be 0. Heat transfer rate in y direction at B will be 0. So Qx at B is equal to Qx at A, Qy at A. That is the expression. How to write Qx at B? How to write Qx at B? At B, so we can say Qx at B is equal to Qy at A. Qx at B in x direction, we can say minus K into area at B into dt by dx at B is equal to minus thermal conductivity is constant, area at section A into dt by dy at A. Thermal conductivity getting cancelled out. What is the area at B? The dimension is 2 meter. Width is, let us say, unity. Width, if you assume unity, width or depth. If we assume width or depth as unity, so area at B will be equal to 2 into 1 into dt by dx at B is equal to, what is the area at A? That is 3 into 1. Area at A will be 3 into 1 into dt by dy at A. That is given. dt by dy at A is given in the question. That is 30 Kelvin per meter. Put the values and get the answer. The only unknown is this. बताइए कितना आएगा? 30 into 3 by 2, 45 Kelvin per meter. Yes, Jabir, very nice. C is the correct answer. Is this clear? The question clear to everyone? किसी को कोई confusion है तो बताइए. Let us move to the next question. Question 3, 4, 5. Again, common data question. Question 3 to 5, common data. One dimensional steady state heat conduction. Steady state का मतलब है Q stored will be 0. with uniform internal energy generation occurs in a plane wall with a thickness of 150 mm. L is 150 mm. The plane wall, or 0.15 meter, and a constant thermal conductivity of 15 watt per meter Kelvin. For these conditions, the temperature distribution has the form. This is the temperature profile parabola. A plus bx plus cx square. The surface at x is equal to 0. The temperature is 100 degrees Celsius. 100 degrees Celsius, that is T naught. And experience convection with a fluid for which T infinity is 20. T infinity is 20 degrees Celsius. And H is convective heat transfer coefficient is 500 watt per meter square Kelvin. The surface at x is equal to L is well insulated. There is an insulation at x is equal to L. So the temperature profile will be like this. Temperature profile agar banaya jaye, it is a parabola, let us say 100 degrees Celsius. The temperature profile will be looking like this. Here it is 100 degrees. The heat flow will take place from right to left. This is. It is insulated, means Q is equal to 0 here. Q is equal to 0, or dt by dx is equal to 0 at the insulated end, at x is. Calculate the internal energy generation rate. Calculate the rate of internal energy generation. What is the answer? Conduction, Jabir. In the previous question, the mode of heat transfer was conduction in the body. The mode of heat transfer was conduction. That is why Fourier law. Fourier law लगाया पिछले क्वेश्चन में. So how to find out the rate of energy generation per unit volume? हम बोलेंगे whatever the heat generated, because it is steady state, Q stored is 0. Whatever the heat generated is equal to heat out. From the energy equation is given as Q in plus Q generated is equal to Q out plus Q stored. And because it is steady state, Q stored is 0. There is no heat entering. So Q generation is equal to Q out. Q generation is Q dot into volume. Volume is equal to area into L. Is equal to Q out is convection, H into area into T naught minus T infinity. Area getting cancel out. You can find out Q dot. वैल्यू पुट कर दीजिए. L की वैल्यू है L is equal to 0.15 मीटर. L is 0.15 meter. From the energy conservation equation, T naught is 100 and T infinity is 20. T naught is 100 degrees Celsius. T infinity is 20 degrees Celsius. Put the value. H is equal to, H is given as 500. What is the answer for Q dot? क्या होगा? What is the answer for question number 3? Answer to question number 3. Solve करिए और बताइए. Option A. Q dot is equal to 500 into 100 minus 20 upon 0.15 watt per meter square Kelvin. The answer will be option A. So Subhan, yes, very nice. प्रथम क्या आंसर आ रहा है? किस यूनिट में लिखा है आपने? You should put all the parameter in their SI unit. It will be 2.67 into 10 to the power 5. 10 to the power 5 होगा. क्वेश्चन नंबर 3 ना? 10 to the power 5 नहीं आ रहा क्या? आ गया ना? 150 mm में मीटर में कन्वर्ट करना होगा. ऐसा यूनिट चाहिए तो 2.67 into 10 to the power 5. अगला पार्ट करिए. Determine the coefficient B of the temperature distribution. Temperature profile is given by A plus Bx plus Cx square. We need to find out the value of B. B की वैल्यू कैसे फाइंड आउट करेंगे? यस है, क्योंकि यहां से इंसुलेटेड है. So whatever the heat transfer rate due to convection is equal to rate of heat transfer due to conduction at x is equal to 0. क्या बोल सकते हैं? At x is equal to 0, Q convection is equal to Q conduction. X डायरेक्शन ये है, H into A into Ts minus T infinity or T naught minus T infinity. T naught minus T infinity is equal to thermal conductivity into A into dt by dx at x is equal to 0. सॉल्व कर लीजिए. dt by dx at x is equal to 0 की वैल्यू, एरिया से एरिया कैंसिल आउट हो जाएगा. व्हाट इज द आंसर फॉर क्वेश्चन नंबर 4? क्वेश्चन नंबर 4, h की वैल्यू 500, T नॉट 100 minus 20. थर्मल कंडक्टिविटी की वैल्यू, thermal conductivity is given as 15 into dt by dx at x is equal to 0, that is b की वैल्यू फाइंड आउट कर लीजिए. ऑप्शन, अगेन ऑप्शन ए, are you getting? B is equal to 2.67 into 10 to the power 3 Kelvin per meter. Option A, very nice. The next part, determine the coefficient C of the temperature distribution. Good. Determine the coefficient C. Temperature is given by A plus Bx plus Cx square. अब ध्यान दीजिए, at x is equal to L. This is x is equal to 0, this is x is equal to L. यहाँ पे insulated है. At x is equal to L, that is equal to 0.15 meter. Q is equal to 0. So dt by dx will be equal to 0. dt by dx at x is equal to L. ये हो जाएगा b plus 2cx is equal to 0. b की वैल्यू ऑलरेडी पता है हमें, 2.67 into 10 to the power 3 plus 2 into c into x is equal to 0.15 equal to 0. You can find out the value of c. Because of insulated surface. What is the answer for C? Question number 5. Isn't it minus 8.9 into 10 to the power 3 Kelvin per meter square? ये टेम्परेचर प्रोफाइल ऐसे बनेगा. यहाँ पे इंसुलेटेड है, द सरफेस इज इंसुलेटेड. यस सुशोभान, वेरी नाइस. प्रथम, जबीर, वेल डन. बाकी लोग भी सॉल्व करिए एंड गेट मी द आंसर. नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 6. क्वेश्चन नंबर 6 पढ़िए और सॉल्व करिए. The outer surface of a hollow sphere, it is a sphere of radius r2, is subjected to a uniform heat flux q2 dash. The inner surface at r1 is held at constant temperature Ts1. It is a sphere. If r1 is 50 mm, r2 is 100 mm, TS1 is 20 degrees Celsius, TS2 is 50. So the heat will flow from outer to inward Q. TS2 is more than TS1, TS2, TS1. It will flow from high temperature to low temperature. Thermal conductivity is given as 10. What is the required heat flux Q2 dash? What will be the heat flux Q2 dash? Q2 dash is the heat flux on outer surface. Q को लिखा जाता है for hollow sphere. It is a hollow sphere. Q can be written as 4 pi K R1 R2 upon delta T upon R2 minus R1. Do you remember the formula Q? The rate of heat transfer is 4 pi K R1 R2 delta T in upon R2 minus R1. Can be written as Q2 dash into A2. And what is A2? A2 outer area is 4 pi R2. यहां से Q2 डबल डैश कैन बी कैलकुलेटेड एज, हम लिख सकते हैं 4 पाई के R1 R2 डेल्टा T अपॉन R2 माइनस R1 इक्वल टू डैश into 4 pi R2 square. 4 pi getting cancel out, then Q2 double Q dash is equal to 1 upon R2 square, then K into R1 R2 delta T R2. Can you solve it? R2 is 100 mm, that is 0.1 meter, and R1 is 0.05 meter. Put the values, you will get the answer. 1 upon 0.1 square, and K is thermal conductivity is 10. Into R1, that is 0.05 into 0.1. Put all the parameter in the SI unit. Temperature difference will be 50. Temperature difference will be 50 minus 20 upon 0.1 minus 0. This will give you the answer. What is the answer for question number 6? Are you getting 3000 watt per meter square? Option B. Are you getting 3000 or not? Option B is the correct answer. Right? Next question. Solve the next one. It is very beautiful question. Two long copper rods of diameter 10 mm are soldered together end to end. There are long copper rods. L is infinitely long. They are soldered together end to end with the solder having a melting point of 650 degrees Celsius. The rods are in the air at 25 degrees Celsius with convection coefficient of 10 watt per meter square Kelvin. What is the minimum power input needed to affect the soldering? Can you just let me know from which topic this question is framed? In conduction, which is the topic? The question is from pin theory. इसको समझिए. There are two. The question is from the pin theory. There are two cylindrical rods, copper rods, and they wanted to be joined end to end like this. They wanted to be joined end to end like this. They are long rods, and there is a soldering need to be performed. There are two rods like this, infinitely long, and there need to be soldering to join them. So whatever the heat supplied through the soldering from the symmetry, we can say Q by 2 will go in this rod, Q by 2 will go in another rod. And because L is infinite, for the infinitely long fin, Q fin is given by KAM theta S. A is the cross-sectional area, KAM theta S. Or you can write H into P to K in for infinitely long fin. Because in one fin it is Q by 2. So what we will write, Q by 2 is equal to under root of H into perimeter into K into cross-sectional area. Q will be equal to twice of under root of H. Area of perimeter will be equal to pi into D into K. Area will be equal to pi by 4 D square multiplied by theta S. Theta S is Ts minus T infinity. Put the value, you will get the answer to Q. Transient का नहीं है. This is from the fin theory. What is the value of Q? Put all the parameters given. H is given as 10. Diameter you should put in meter. Diameter is equal to 0.01 meter. Put all the parameter in the SI unit. Ts is given as, Ts is 650. This is the surface temperature. Ts is 650 degrees Celsius. And fluid temperature is, thermal conductivity is given as 379. Fluid temperature is 25. Can you do the calculation and let me know the answer? The values and do the calculation. Number 7. Please do the calculation and let me know. And if the concept is not clear, please do let me know. Because there are two fins. And whatever the power input for soldering, half of the power will go into one fin and half of the power will go in another fin. That is why we need to multiply with 2. That is why 2 comes into picture. Are you getting option B or not? 120.9 watt. Are you getting option B or not? So Soban, please check your calculations. It should be 120.9 watt. Option B. Why are you getting 240? It means you must be getting twice. Q by 2 will be equal to, that is where you must have committed mistake. Q by 2 is equal to Q fin. Because there are two rods. There are two rods. So in each rod, the power transfer or the heat transfer will be Q by 2. Right? The next question, question number 8 and 9, common data. Again, common data question. A pipe is covered with asbestos. Thermal conductivity of the asbestos is given as 0.17. Insulation and is exposed to the room air at 20 degrees Celsius with H is equal to 3. The pipe temperature is 200 degrees Celsius. 200. And it is covered by asbestos. And the diameter of the pipe is D naught. 50 mm. You should convert it into meter. In the above problem, if the pipe is not covered with the insulation, the heat loss by the pipe is. The loss of heat, if there is no insulation, the loss of heat is due to convection. So Q bare is equal to H into surface area available for convection into delta T. Put the values. The pipe is very long because length is not given. It will be H. What is the value of H? 3 into area will be equal to pi dl. Pi into D. D will be equal to 0.05 into L. The answer has to be in watt per meter into delta T. That is 200 minus 20. Q by L. The question is about Q by L. You can find out Q by L. What is the answer? Can you find out Q by L? Question number 8. Are you getting option C or not? 84.8 Q by L is equal to 84.8 watt per meter. Option C. Without insulation. And the next part is, in the previous problem, if the insulation is applied for critical radius, if the insulation is applied for critical radius, the rate of heat transfer will be maximum. Then what is the heat loss by the pipe? First of all, you need to find out the critical radius of insulation, K by H. K is given as 0.17, H is 3. So critical radius of insulation will be how much? 0.0567. And now how the heat transfer will take place? There is a conduction in asbestos. The heat will flow due to conduction in asbestos, and then there will be convection. So it is a combined mode of heat transfer. If you draw the circuit diagram, R conduction will be equal to ln of R CR by R naught upon 2 pi KL. And convection, this is conductive resistance. And what is the convection resistance? This is T naught, this is T infinity. Convective resistance is 1 upon H into area. Which area will be taken into consideration? Outer area. That is 2 pi RCR into L, isn't it? Q insulation will be equal to delta T, that is overall upon RE. That is T naught minus T infinity upon R conduction upon plus R convection, because they are for the series combination. कर सकते हैं क्या? Can you solve and get the answer? Pipe temperature 200, environment temperature 20. Put the values. So Q insulation is equal to 200 minus 20 upon ln of RCR is 0. What is RCR? Critical radius. That is 0.0567 upon R naught. It will be R naught. What is R naught? Diameter is 50 mm, so R naught will be equal to 25 mm or 0.0 meter. R naught will be 0.025 meter. 0.05 upon 2 pi. K is 0.17. Thermal conductivity 0.17. Asbestos plus 1 upon H will be equal to 3 into 2 pi RL, RCR, that is 0.056. Q insulation by L, find out. Can you do? L is the length. L is the length of the pipe. It is having the insulation like this. It is having the insulation over the periphery. The insulation is on the periphery. L is the length of the pipe. So area will be 2 pi RL. Area will be 2 pi RL. Put the values and get the answer. Watt per meter mein. The options are in watt per meter. Watt per meter. Are you getting around 105? Yes, Susuban, it is 105.7 watt per meter. Option A is the correct answer. Very nice. Good, good, good. थोड़ी calculation है इसमें, but the concept should be clear. R conduction is equal to ln of RCR by R naught upon 2 pi KL. R convection is equal to 1 upon HA, but area will be equal to outer area 2 pi RCR into L. दोनों को ऐड कर देंगे तो R इक्विवेलेंट आ जाएगा, that is R conduction plus R. ऐसे डेल्टा T upon R. पर यूनिट लेंथ पूछे प्रथम, अगला क्वेश्चन सिंपल है, नेक्स्ट क्वेश्चन सॉल्व करके बताइए. क्वेश्चन नंबर 10 एंड 11 अगेन कॉमन डेटा क्वेश्चन. क्वेश्चन नंबर 10, a wall 300 mm thick, the thickness of the wall is 300 mm, is made up of two layers A and B. There are two layers A and B like this. Composite system, it is a composite wall. The temperature is shown in the sketch. T1, this is 0.1. T2, this is 0.2. T3, this is 0.3. Temperatures are given. T1 1325, T2 1200, T3 25. The ratio of thermal conductivities of the two layers is Ka by Kb is 2. Find the ratio of thickness of two layers La by Lb. What is the ratio of La by Lb? What is La by Lb? La by Lb की वैल्यू क्या होगी? Q will remain constant, that is Ka delta T by L. Q की वैल्यू कांस्टेंट क्यों होगी? क्योंकि why Q is constant? Because Q generation is 0 and Q stored is 0. Q generation or Q stored 0. Q की वैल्यू कांस्टेंट. From here what we can say, L is proportional to area will be constant. Area constant होगा, area will remain constant. L will be directly proportional to K into delta T. L will be proportional to K into delta T. अगर हमें LA by LB चाहिए, if we want LA by LB, then we can write Ka by Kb into delta TA by delta TB. सॉल्व कर लीजिए, ये डेल्टा TA है. डेवलप द रिलेशनशिप, ये डेल्टा TB है. Ka by Kb given at 2, delta TA 1325 minus 1200 numerator, and what is delta TB? That is 1200 minus 25. What is the answer? क्या आंसर? आंसर बताइए. What is the answer? Are you getting option A or not? Option A is the correct answer. Next part, second part of the question. What is the thickness of layer A? What is the thickness of layer A? LA की वैल्यू क्या होगी? LA by LB की वैल्यू हम फाइंड आउट कर चुके हैं 0.213, and LA plus LB, and we know LA plus LB is equal to L, जो कि गिवन है 300 mm. अगर LA यहां कॉमन ले लें तो 1 plus LB by LA is equal to 300 mm. सॉल्व कर लीजिए. LA 1 plus LB by LA की वैल्यू होगी 1 upon 0.21 is equal to 300. can find out the thickness of A. What is the thickness? अगर सिर्फ मेहनत, जितनी ज्यादा मेहनत करोगे उतना ही सिलेक्शन होने के चांसेस बढ़ेंगे. The hard work is the only key to success. The thickness of layer A, the more you practice, the more you revise, the more you study hard, the more is the better chances, the better is the chances for the selection. What is the correct answer for question number 11? Option A will be the right answer. 52.6 millimeter. आ रहा है क्या 52.6 mm? Are you getting it? The next question, question number 12. Question number 12. From where the question is? Question number 12. इस टॉपिक से. What will be the time required to cool a steel plate of 36 mm thickness? There is a steel plate. Thickness is 36 mm. From the initial temperature of 500 degrees Celsius, initial temperature is 500 degrees Celsius to 325 degrees Celsius. T is 325 degrees Celsius by placing the plate into a liquid at 300 degrees Celsius. Steel has the following properties: thermal conductivity of steel, specific heat and density are given. The coefficient of heat transfer between the plate and the surrounding, that is H, is also given. ये है unsteady state conduction से. The question is from unsteady state conduction. The analysis is done by using lump system. What will be, question क्या है? What will be the time required? The time required will be how much to cool the plate from 500 degrees Celsius to 325. आप बता सकते हैं what is the characteristic length? V upon surface area. For a plate, the characteristic length will be L by 2. Volume is area into L. L is the thickness, let us say L is the thickness. And surface area is 2A. Area getting cancelled out. The characteristic length V by A is equal to L by 2. And thickness is given as, L is given as 36 mm. For lump system analysis, theta upon theta I is equal to T minus T infinity upon Ti minus T infinity is equal to e to the power minus HA by rho CV. यहाँ से टॉ फाइंड आउट करना है. टॉ को लिखा जा सकता है rho CV by HA. If you take the log on both sides, if you take log on both sides, होगा ln of Ti minus T infinity upon T minus T. एक्सप्रेशन बनेगा क्योंकि नेगेटिव साइन भी था, इसलिए Ti minus T infinity न्यूमरेटर, T minus T infinity डिनोमिनेटर. टॉ विल बी इक्वल टू रो. डेंसिटी क्या है? 7800. स्पेसिफिक हीट 0.5 किलो जूल है, यूनिट है किलो जूल. 0.5 इंटू 10 to the power 3 इंटू वॉल्यूम अपॉन एरिया. सरफेस एरिया को लिखा जा सकता है L by 2. 36 by 2 that is 18 into 10 to the power minus 3 upon H. Convective heat transfer coefficient is given as 25 into ln of Ti कितना है? 500 minus 300 upon T that is 325 minus 300. कॉल कर लीजिए. टाइम सेकंड में मिलेगा. क्वेश्चन है आर में कन्वर्ट करना. 3600 से डिवाइड कर दीजिए, यू विल गेट योर आंसर इन आर. सेकंड में बताइए पहले मुझे. आर यू गेटिंग? 5839 कितना आ रहा है, क्या चेक करिए. 5839 second. 5839 सेकेंड. R में कितना होगा? डिवाइड बाय 3600. It will be 1.62 R. It will be 1.62 R. Option A. फॉर्मूले याद होना चाहिए लंप सिस्टम एनालिसिस वाले. सिंपल फॉर्मूला बेस्ड क्वेश्चन है. आर यू गाइस गेटिंग इट और नॉट? नेक्स्ट क्वेश्चन. नेक्स्ट क्वेश्चन सॉल्व करके बताइए. क्वेश्चन नंबर 13. ए प्लेन वॉल हैज यूनिफॉर्म हीट जनरेशन. जनरली हम Q डॉट से डिनोट करते हैं. 1.5 into 10 to the power 6 watt per meter cube. Having thickness 50 mm. Thickness L is 50 mm. The outer surface is cooled by water stream. ये outer surface है. ये inner surface है. The outer surface is cooled by water stream. Mode of heat transfer will be convection, where H is 1000 watt per meter square Kelvin. Determine the temperature of the cooled surface. T2 find out करना है. What is the value of T2? Inner surface का कोई cooling नहीं है. इसका मतलब there is no heat transfer from the inner surface. We can have inner surface to be insulated. So from the energy equation, Q in plus Q generated is equal to Q out plus Q. Q stored will be 0, no mention. Q in will be equal to 0 because the heat is leaving. So whatever the heat generated is equal to heat leaving by convection. So heat generated कितना होगा? Q dot into volume, that is area into L, is equal to heat leaving by convection H into area into T2 minus T in. Area से area cancel out. Q dot की वैल्यू हो जाएगी H is given as 1000 into T2 is unknown minus T infinity is 30. टेम्परेचर डिफरेंस अगर है तो केल्विन में या सेल्सियस में किसी भी ले सकते हैं. एंड 0. यहां से T वैल्यू फाइंड आउट. डिग्री सेल्सियस में आ जाएगा T2. व्हाट इज द आंसर फॉर T2? Q डॉट गिवन है. डॉट की वैल्यू दैट इज 1.5 into 10 to the power 6. T2 की वैल्यू 105. The temperature T2 will be 105. समझ में आया क्वेश्चन? कुछ असाइनमेंट क्वेश्चन मैं दे रहा हूं आप लोगों को. ट्राई टू सॉल्व. देयर आर 4 पार्ट्स इन दिस क्वेश्चन 14 to 17. दिस इज द डेटा. देयर आर 4 असाइनमेंट क्वेश्चन. ट्राई टू सॉल्व दिस क्वेश्चंस and I will share the solution to my telegram group. 14th, 15th, and I will share the PDF of this session also to my telegram group. 16 and 17. There are 4 parts in the question. इनको solve करिए और अपने answers comment section में भी लिख सकते हैं इस session के. And do like this session and share this session to all your friends. And if you have not subscribed the BYJU'S YouTube channel, please do that so that you will be getting all the notifications of our free classes which we take from time to time. Tomorrow again at 10:45 PM, I will be coming live and discuss the questions from the convection mode of heat transfer. All right. ठीक है, चलो कल मिलते हैं 10:45 पे. प्लीज रिवाइज द कॉन्सेप्ट ऑफ कन्वेक्शन, ऑल द फॉर्मूला. इट कन्वेक्शन इज हैविंग लॉट ऑफ फॉर्मूला. प्लीज डू रिवाइज बिफोर कमिंग टू द नेक्स्ट क्लास. एंड इफ यू हैव नॉट ज्वाइंड मी ऑन द टेलीग्राम, दिस इज माय लिंक फॉर ज्वाइनिंग द टेलीग्राम एंड यू कैन ऑलवेज कॉन्टेक्ट मी थ्रू द मेल ID which is there on the screen. All right, with this note, let me take your leave. Stay safe, stay motivated, and keep preparing with your full dedication and hard work. Good night, guys. Thank you very much for being part of this session. See you tomorrow. Jai Hind.